Morning. Okay, let's go ahead and get started. So, did y'all get your exams in? Good. Well, that means you passed because everyone who turned their exam in has gotten a fantastic grade on that exam. It's a good job, guys. We'll probably end up going over the exam on Friday. I'm just still waiting for like one or two more to come in, so I'm not going to go over it quite yet. But we're going to go and start on a new section, and that is radicals. So we've been talking about exponents. The opposite of an exponent is a radical. They do opposite things. So, you're probably familiar with something like this: square root of 4. If it'll show up, please focus. It's the weirdest thing. Come on. It just really does not want to pick that up. How strange. I'm gonna restart this thing. Hey, there we go. And that's the wrong one. There. Sorry about that. So again, you are probably familiar with something like square root of 4. So what would you say this is? 2? Yeah. Okay, why are we saying it's 2? What are we looking for when we ask ourselves what a square root of a number is? Yeah. You know, I never thought about it like that when you said like half a number.
Yeah.
It is kind of like half a number, but in a different way. Yeah.
That's always like how I got it, especially with like 4, because 2 times 2 is 4. And it's like, you kind of set the number, like, you have to like think what's like, I don't know, it's hard to explain, but like.
Yeah, I know what you mean though.
Like 32 to 16.
Yeah.
Yeah, like 32 times, or no, 16 times 2, I think.
Is 32?
Yeah.
Yeah.
I don't know. That's just how I always thought about it.
Neat. I like that. Okay, so yeah, what we're looking for when we have a square root is what times itself equals the number underneath that root. And if you don't see a number in the crook here, it means it's a square root. But we can also have a 2 there to represent a square root. Okay, so what about something like square root of, well, I don't know, 81? What's that one? 9. Yeah. Okay. So most of us probably know a few of our perfect squares. That's what these are called, is perfect square numbers. So things like 4, 9, 16, 25, so on and so forth. Okay? And those are going to be pretty useful for going through this part of the course. Because what if we have something like this? Square root of 50. Does 50 take a square root evenly? Does it come out with an integer number? Huh? It's not an integer. An integer is like a single number, like 5 is an integer. This comes out to be an irrational number. We can kind of estimate what it would be, though. Okay, so we know our squares. What is a square number that's close to 50? So something like 25. We can get closer, though. 6 is 36. We can get closer. 7 times 7. What does that come out to be? 49. So we know that the square root of 49 is 7. So this is just above that. And 8 times 8 is 64. So this thing has to be somewhere between 7 and 8. Now we could also just plug it into the calculator. And for fun, let's see what that is. 50 is, let's see, 7.0710678118, so on and so forth. Again, it's an irrational number. So it has a decimal on it that keeps going on and on and on and on and on and on and on infinitely without ever having a pattern. But yeah, once we plug it in the calculator, yeah, it's just above 7. All right, well, is there something else that we could do to this instead of getting that approximate answer? Again, we don't like approximate answers typically in math because that means we're losing some data. We're losing some numbers there. And we don't want to do that when we want to keep calculating. So what we can do instead is we can simplify this root, this irrational number. And what I mean by that is, in this number, 50 in this case, there might be a square number hiding somewhere. But to find it, we're going to need to factor this number. In other words, find all of the prime factors. And the way we start that is just ask ourselves, what are 2 numbers we can multiply to get 50? Any 2 numbers. 5 times 10, yeah. Okay. So we know 5 times 10 gives us 50. What about 10 times, or what do we multiply to get 10? Good. Now, we can't break down that 5. It's prime. Same thing with these numbers. They're both prime. In other words, we've run out of things that we can break down. These are the prime factors of 50. So we could multiply 2 times 5 times 5 to get 50. Wait a minute, let's hear that again. 2 times 5 times 5. That is a square. Of course, what is 5 times 5? 25. What's the square root of 25? 5. Or another way you can look at this is if you find a matching pair of numbers like this, that number gets to come out. Because 5 times 5 is 25, and what's the square root of 25? 5. So that 5 comes out as a whole number. We still have a square root though. That's because there's a number left over that wasn't able to match up, can't break up anymore. Which one is it? 2. Yeah. So there's all the prime factors taken care of, and there's our answer. The simplified version of square root of 50 is 5 times the square root of 2, or 5 square roots of 2. That's actually pretty nice because square root of 2 is a much simpler root, and thus can probably match up with other things like it. We'll see that a little bit more later on though. Right now, let's keep practicing this simplifying thing. Any questions before we move on? All right. So let's try square root of 48. So again, we got this thing. It's just below 7, so it's somewhere between 6 and 7. 6 times 6 is 36, 7 times 7 is 49. So this is somewhere between those. And thus it is irrational, and we want to simplify it. So we want to break it up. What two numbers can we break it up as? 2 and 24? Okay. And by the way, it does not matter what you start with. We're starting with 2 and 24 here. We could also start with 6 and 8.
4 and 12?
Yeah. Anything. As long as it multiplies to get that original number, it works. All right, well, 2 is prime. What about 24? 2 and 12? 12 can be broken up more. What? Is 6 and 2? 6? 3 and 2? Hey, I think we finally got to the bottom. So again, do we have any matching pairs? Yeah, we have 2s. In fact, we have 2 pairs of 2s. Again, anything that makes a matching pair like that, you get to take that exact number out. So this 2 for this matching pair here comes out. A 2 for this matching pair also comes out. But there's got to be some kind of operation between them, either add, subtract, multiply, and divide. Which one do you think? Multiply, good. If we were multiplying in here, we better still be multiplying here. All right? And then there's something left underneath that root. What is it? 3. All right, well, 2 times 2 is what? 4. So really this is 4 square roots of 3. Make sense? Good. What questions do we have? None? All right, let's try another one. This is going to be not the square root, but the cube root. There's more than just square roots out there. Cube root of 24. Now remember that a square root asks what times itself is going to give me this number underneath the root. A cube root is asking basically the same thing, except instead of having a pair of something that matches, so like 2 times 2, we want a triplet of numbers, triplet of the same number. So like 2 times 2 times 2. Okay? But the method is the same. We want to just break up 24. So what can we break it up as? Any 2 numbers that multiply to get 24.
Okay.
4 and 6. All right, so we can break those up now. What can we break 6 up as? 2 and 3. How about 4? 2 and 2. So again, we're looking for a triplet of numbers. Do we see one? Yeah. We've got a triplet of 2's here, which means we can take a 2 out. And what's left underneath that cube root? 3. So we have 2 cube roots of 3. Very good. What questions do we have? None? All right. Now, this will work for any type of root that you have. We've done square roots and cube roots here, but you can do 4th roots, 5th roots, 6th roots, 7th roots, whatever type of root. Just keep in mind that the number in this crook is telling you how many numbers need to match. So like for a cube root, we need 3 numbers to match. We got those 3 numbers here. Square root, we don't usually write the square in there, but we can put a 2 there. That means we need 2 numbers that match, just like that. So a 4th root would need 4 numbers that match. 5th root needs 5 numbers that match, so on and so forth. Okay? So let's try this. Square root of 12 plus square root of 27. Now, as it's written here, there's not anything that we can do with these 2 numbers. Remember that when we add or subtract numbers, they have to have like terms. And for roots, that means that the number underneath that root needs to match. You might have been hearing me say our answers a particular way. For instance, this one is 2 cube roots of 3. What we're saying in here is I have 2 of these cube root of 3 things. Here I've got 4 square roots of 3. That's how many square roots of 3 I have. I have 4 of them. Here I have a single square root of 12 and a single square root of 27. Well, those things are not the same type of thing. It's like trying to add apples and oranges. But like we've seen, maybe there's something hiding in here that we can get out by factoring to make these match. So, let's start with square root of 12. What can we break that up as? Okay, 2 and 6. And 6 is? So, we've got a matching pair. What comes out? And what stays in? So we have 2 square roots of 3. Then we drop that plus down. How about 27? Twenty-seven is what times what? 9 times 3. And 9 is... So we've got a pair. What comes out, what stays in? 3 square root of 3, yeah. So hey, now if we look at this, we have 2 square roots of 3 and 3 square roots of 3. So how many square roots of 3 do we have altogether? How many?
How many square roots of 3?
How many do we have altogether? Because we have 2 of them here and 3 of them here. 5. Again, this number out in front is just saying how many of these things we have. So we have 2 of them here and 3 of them here. We have 5 altogether. Any questions? None. All right. Let's try another. 2 square roots of 18 minus the square root of 32. So we're subtracting here, but it's the same idea. We cannot combine these unless we have like terms. So, same technique. We want to simplify these. What can we break up 18 to be? Okay. Then 6 is what? Okay. So when we simplify this whole thing, what do we get? 3 square roots of 2, good. Now, there's something important. We had a 2 on the outside to begin with, and it's still got to come down. And what are we going to be doing between that 2 and 3? Multiply. Absolutely. Yep. 6 square roots of 2. Okay. So now we drop the minus down. 32. What are its factors? Okay. Then 16. 8. Okay, so how many pairs of 2's do we have? 2 of them. Which means what's going to be on the outside? Go ahead and multiply.
4.
Yeah. So we got 4 square root of what? 2. Alright, so we got 6 square roots of 2 minus 4 square roots of 2. How many square roots of 2 do we have? 2. Perfect. Any questions? Do we feel like we're getting it? Okay, good. So again, basic idea here. These roots that don't exactly have a integer answer, they're not perfect squares. Sometimes they have things hiding in them that are perfect squares. So like for 32. 32 is 16 and 2. Now, let's ignore all the stuff that we broke out of 16. What other way could we think about this 16? 4 times 4. So if we had this, we know it's 4 and 4. Would we really need to keep going? No, because we have a match there. So we could just say it is 4 square roots of 2. Hey, same thing we got down here. Again, no matter which way you break these down, it'll always work as long as the thing that you break out of it multiplies to get the thing above it. But again, a lot of these numbers have things hiding in them that are perfect squares, and that's what we're looking for when we break these down. Then you have numbers like square root of 6. Yeah, there's not a whole lot we can do with it. But this does bring us to what we're going to be covering on Friday. What if I add this? Okay, so we know 6 is 2 and 3, and we know 2 is 2 and 1. And we can make a match across those trees. Since everything is multiplying down here, and everything is multiplying up here, it means that we actually have one tree here. So this would be 2 square roots of 3. Okay, but again, that's going to be Friday. So any questions before we leave today? Nope, alright. Seems like there's not a whole lot of people attending today, so that's why I'm cutting it short. I don't want to get too far ahead of them. Hopefully they come here on Friday. And I hope y'all have a great day. Again, good job on the exam. Grades for that should be going out tomorrow. I should have all the exams in by tomorrow. And then we'll go over the exam on Friday. Have a good one. You too.